Welcome to Natural Habitat Adventures Daily Dose of Nature. I'm your host, Kendall Bauer, and today's presentation is Nature's Decoders, Unraveling the Mystery of Lichen, presented by NatHab Expedition Leader, Nikki Sentinella. Nikki, it's such a pleasure to hear from you today. I'm going to hand it off to you.
Thanks, Kendall, and welcome everyone. Good morning where I am, so we'll be sipping coffee, but I hope you're all comfortable and ready to dive into unraveling the mysteries of lichen. This has been part of a little bit of a series where I'm looking a bit more generally at indicators of the natural world around the world. So regardless of where you're from, there's usually something that you can spot, and if you know how to read the language, then you can pick up quite a lot of cues as we move through this landscape. I'm presenting today from a Wabakal country here in Australia, just a little bit north of Sydney, and it's nice and early, so we'll jump in and have a look at what lichen can tell us. So if you haven't seen me before, my name is Nikki, and I have slides that do change. There we go. I am an expedition leader here with Natural Habitat Adventures, and I've been here for a couple of years. And when I'm not guiding, I am also a conservation biologist, working in, at the moment, some restoration fields around the state of New South Wales. I'm a naturalist and a photographer, so I knew a few things, and I happen to have quite a few photos of lichen in my gallery, which was very handy. So what are we going to look at today? Today we are going to find out what lichens are. We're going to go into a little bit of depth there, just understanding that relationship. And we're going to talk about how we classify lichens. Usually this is done in a fairly accessible way on the first pass, and that's done through growth forms. So the way in which they grow will give us an indicator on how they look, and how we actually name them, which is really helpful for finding them later. We can actually use these lichens as a form of navigation. It does vary depending where you're from, but there's a few clues that we can start to look at to determine maybe the direction of the sun or the dominant winds or rains. And we can even start to age things through a process called lichenometry. We'll talk about that, but we can actually use lichens to get accurate dates. We'll talk a little bit about the relationship between lichens and animals. In quite a broad sense, we'll look at some things for lichens being used as food by animals and humans. And we'll look at some of the other relationships that we have with lichens and animals. And we'll talk about lichens in space, which I just think is a really cool area of research that has been going on for well over a decade now, but there's some new stuff that's coming out that's pretty interesting. So let's jump into some lichens. There will be questions at the end, so if you think of anything throughout the presentation, do just drop a question in, and Kendall will read them out for us at the end. Let's have a look at lichens. We're going to ignore the lovely Rachel from the World Wildlife Fund here in Churchill. We're going to ignore her beaming happy face as she's just seen her first polar bear on the way in. And we're going to have a look up here at this beautiful Inukshuk, and we can see this orange spreading across the rock here. This is a common indicator that we see of lichen. It's really quite striking. We'll zoom in a little bit further. This is not my photo, I wish. I haven't done too much macro photography of lichen, I am now realizing as I put together these presentations. This is a photo I've just pulled from Jason Hollinger, and it's a really beautiful up-close view of an orange lichen. And I get asked all the time, why did someone paint that rock orange? Or why has someone spattered something across this wall? The really bright colors can just be the natural pigments in lichens. So what are they? They are a colorful thing that seem to grow on absolutely nothing. They don't seem to be acting like plants. They're not necessarily in the soil. We often see them growing alongside some mosses. So I will talk briefly about moss just to separate them so we can see the differences there. But I also want to define some components of what lichen is. And the first of that is our fungi. So our fungi you can think of as our classic mushroom. The mushroom is actually the fruiting body of the fungi. So the fungi is actually extending underneath the ground. You may have heard of the mycorrhizal network, or the mycelium network, or the worldwide wood, which are all various terms that have described this really fine layer of many, many, many different species of fungi underneath the ground layer, so in the soil. But generally, we're thinking mushrooms, as they start to present, they're actually the fruiting body. They're releasing their spores for reproduction. That's why we're seeing these mushrooms come through, often after a nice juicy rain that'll help things move around. But also things like our yeasts and our molds are also fungi. They are considered eukaryotic, and I'm putting that in because we're going to look at something that is prokaryotic. Eukaryotic just means multicellular, so it's made up of multiple cells as the same organism, as opposed to prokaryotic, which is a single-celled organism. And they're heterotrophic, so they don't make their own food. So a good distinguisher for our fungi, generally we're not seeing those bright greens. We're seeing those browns, reds, purples, all those other colors. And they are mainly getting their food from absorbing those nutrients, either from decomposition. So as that material breaks down in the soil, they'll be absorbing those nutrients, and sometimes as well through parasitism. So they're parasites as well, depending on the species. It's not a one-size-fits-all for fungi at all. They're hugely diverse, and they come in so many different structures. Just think about how it would be to grow these beautiful turkey tails on this log behind compared to a standard mushroom. And then compare that to microscopic hairs running underneath the ground for sometimes hundreds of kilometers. The largest organism in the world is a fungi. If you count that fungal network, that is all the same species and genetically all identical, it's the same individual, it's the largest organism in the world. So mushrooms and fungi and yeasts and molds, hugely different. And these differences in structure become really important for lichens. The way that they're able to maintain and hold these different growth forms all over the world makes them a really, really good house builder. Now, the other player I want to introduce you to is algae. Algae we often picture in the water, these beautiful, slimy, probably quite slippery greens as it's washed up here. And it can also range in size. If we think about tiny little microalgae, we think about the algal components that make up our phytoplankton. So we think phytoplankton that has algae in it, all the way up to our giant kelp. So again, really quite adaptive with their structure, but it's actually not as strong. We're mainly seeing them in this aquatic environment because that aquatic environment is able to sustain more of a structure around it. Think about when you go for a swim and you feel a bit more supported. So you don't actually have to have as developed structures. And this is a difference that we see from algae to plants. So our algae is photosynthetic, so it produces energy from the sun. It's really important to start the food chain around the world. And it's really, really productive in the oceans. We get a lot of our energy globally is from our ocean algae. So they can produce their own food. So plants can do that too. So how are they different? If we look at more of a cellular and structural level, you can sort of imagine that algae have fewer bones. Bones isn't obviously the way that we're looking, but on a cellular level, it's that structure. So we don't have as many kind of organs in that would define a stem and a leaf and a trunk. We have a general sort of stem, and then it extends off into these leaf-like structures that are called blades in kelp. So if you've ever picked up kelp on the beach on the side of the tide that's just come in, it's going to be quite floppy and fall over. It doesn't necessarily sustain that structure when it's out of the water. And that's something that I think about a little bit when I'm comparing an algal plant, an algae compared to like a seagrass. If I pulled a seagrass out, you can get those beautiful ribbon seagrasses and they hold their structure. So structure is something that they're kind of lacking out of the water, but they do make their own food. So we want to think about that containing their food and then the fungi of that structure. Now I'm going to introduce you to a third player. The third player is cyanobacteria. The cyanobacteria, these are prokaryotes. So these are single-celled organisms. And these were the first things to photosynthesize. If you happen to catch Eleanor's series here on the Daily Dose, she did a beautiful series on extinction events. And she did one called the Great Oxygenation Event. And that was looking at when oxygen was really first introduced into the Earth's atmosphere through these guys. And so it was with the cyanobacteria producing that oxygen from that photosynthesis, converting that energy into food. It changed the entire Earth's landscape. We saw color shifts, we saw new species develop, and we saw these cyanobacteria, these single-celled organisms, actually consumed by other single-celled organisms. And this is when we started to get our multicellular life, and this is where we started to get our chloroplasts, which is where the photosynthetic process happens. So if we go to an algae, within that cell is a smaller contained cell, which we call an organelle, that actually does the photosynthetic part. So it was thanks to the cyanobacteria that the algae can photosynthesize. But we still see cyanobacteria on its own today as well, which just shows how resilient and adaptive and well-placed it is in our environment. So that's a lot of talk about things that are not lichen. So what is lichen? So if anyone's been on often our trips to Churchill, you may have heard this story before, but I'm going to tell it through a little bit of a story. And so we can imagine that we have Freddie the fungus, who we've just met, and Freddie is really, really good at building a house, has amazing architectural and engineering skills. It looks good and it's structurally sound. And so Freddie can build an amazing house, but isn't a very good cook. And all this beautiful space needs to be filled with something. And then along comes Alice the algae. And Alice the algae is a great cook, but isn't quite as supported within her community. And trying to move out into the drier landscape needs some sort of protection. So Freddie the fungus and Alice the algae can get together. Alice can make all the food and Freddie can provide the structural support of the house. And they really took a liking to each other. Though some say their relationship's on the rocks. They actually introduced sometimes a third player, and that would be Cecilia, the cyanobacteria. And Cecilia can make a lot more food as well. So we can come together with this beautiful symbiosis between fungi and algae to make our lichen. But we do also sometimes see two species of algae, or we may see a species of algae and a species of cyanobacteria. So we see these different components, which are different species, in the one structural unit that is lichen, that we call a species, even though it may have two or three. So it is very, very unique relationship. And it is really a perfect symbiosis. There is a lot of sharing going on. One is not benefiting more necessarily than the other over the lifespan. And it means that as that symbiosis is quite stable, it can grow on other things like a tree or other plants, and it's not going to take nutrients necessarily from that tree in a parasitic relationship. So they are really considered their own unit, and we do often refer to the species of lichen, even though it is made up of multiple components. So the fungi is providing that structure and the algae is providing the food. This is a really lovely little diagram that shows a cross-section of lichen. And so all of the white that you can see is our fungal network. We have these beautiful hyphae, which are these like hair-like strands. And then this really nice shell on top. And we have these almost look like roots, but these are our anchoring points. And they're all done by the different fungi. And the way that they grow is dependent on which fungi they are with. The little green dots, The little green dots are the food making machines, and these are our algae and our cyanobacteria. So lichen is very complicated already, and that's just within it in a cellular level. And then when we start to look at the beautiful macro structures that they can make, we get to see some really amazing things happen that we don't see anywhere else within the other kingdoms of life. So what's moss? I just want to touch on moss quickly because often we see them lichens and mosses right next to each other, and we often see similar sort of growth forms. Now, mosses, they are plants. They are, truly speaking, plants. They're considered non-vascular. So non-vascular means they don't have a kind of structured vascular system with our xylem and our phloem, which is our water pipe and our food pipe that go through a lot of our standard plants as we imagine trees and your house plant. They'll often be vascular plants. They do have a vascular network. They still move water about their body and nutrients about their body, but it isn't structured in that way. They are flowerless and they don't have seeds. So these will quite easily distinguish us from a lot of the plants, the larger plants that we see around. They produce spores. So in this picture, you can see some little brown spikes coming up with little caps on top. Those little caps contain a whole bunch of spores, and I actually, out in the field, I brushed my finger across it, and you can see this little fine dust come out from each of those little cups, and that's the spores of the moss coming through. Those spores are then released and they go into this nice wet damp environment and they mix in that water, and then they come together and they produce a new moss. And so normally they're just reproducing with those little cups that come through, and then they have this beautiful wet environment. So when we're looking down at mosses, we're looking for tiny little feathery leaf-like structures. They may be standing up a bit more upright than you would expect perhaps a lichen. Because of our algae and our cyanobacteria, we see a lot of lichens are that stereotypical blue-grey green, as opposed to a really vibrant green. But we'll see a couple of quite green lichens later on, which will throw a little bit of a spanner in. But if you get down close and you have a little bit of a look at the features, you should be able to distinguish all of these. So if we have a look here, we have a beautiful rock orchid. That's the really fleshy leaf. We have some sphagnum mosses up the top. We also have some lichens in here, which have our fungi and our algae, maybe even our cyanobacteria. And we have a couple of little mushroom cups coming out here, which are our fungi. So all within a couple of square inch, we have so much diversity. Now, if you imagine on this tiny little section of a rock wall, we have plants, algae, fungi. We may have cyanobacteria, which are our single-cell organisms. Maybe in here there's a single insect. That's not much of a stretch. So we could have 5 kingdoms of life all within this tiny little picture. So next time you're walking through a green wall, stick your nose in it and have a little look up close. We don't just see lichens on signs as well. I think this is quite a common thing that we see, sort of old things overgrown with lichen. We do also have other signs that we can read from the lichen. So we're going to look at a couple of the growth forms. The lichens are often characterized by their color and their growth form. So here are some nice fancy words. If you want to take a photo of this, or it'll be up on the video at the end. If you want to get your lichen terminology up, these are some of the terms that would be useful for classifying your lichens. But we can have a little translation here. So we have our fruticose, which is shrub-like, foliose, like foliage, leaf-like, crustose, cross-like, nice and easy. Squamulose is scaly. So imagine, as opposed to crust-like would be like paint that has been chipped and you've got all of these lovely fine cracks that come through. The scaly version would be those little crusty sections lift up at the end and they're like individual scales. So they look a little bit more pronounced, I would say. We have leprose, which is powdery or like dusty. You often see these quite underneath logs or on the edges, dusting on soil as the tree comes down into quite a dark area. That's where I often see these dusty ones. We have gelatinous, which we often don't think of for our lichens, but they can actually be jelly-like. And we have our filamentous, so stringy or hair-like, if you imagine all of our wispy witch's hair hanging down. So there's quite a lot of descriptors here, and there are more. There's about 20,000 species of lichen. So we won't know all the names, but you can learn the common ones in your areas. And this is a really useful way for you to know how to look them up. If you use search terms like this, it'll be much easier to identify the lichen in your area. And you may also be able to take a photo, and if you use something like iNaturalist, it might be able to ID the lichen for you, or a researcher on the application will ID it because they love doing that. That's what I do in my free time, not for lichens, but go through and ID some things. So you may see these signs. This is in BC, British Columbia, Canada, and I often see lichen signs at the start of trails, and it's worth having a little look now that you have a bit more lichen literacy. And you can see that this actually names some of the common names for the lichens in this area. So it's got the crust lichen, they call it in this area bullseye. And so you're starting to learn some of those local species. So have a look at those little signs. They may actually be covered in some lichen, but it's a good way to understand what we've got. Now, common names are really helpful in your area, but something to bear in mind, common names are going to change all around the world. So what you call something at home may be a completely different species to something you call overseas. And common names have often come from how a thing looks. So it means that we get lichens called reindeer moss or deer moss, and it's not a moss at all. It just looks like it resembles a moss. I think now, hopefully, we can have a little look, and it should start to look a little different. So just bear that in mind with common names where you are. So now when we go out for a walk, this is in a temperate rainforest, there's quite a few mosses here and there's a few lichens. We can even see some dusting on the left side here, and we see some dusting lichens going on. So we can see some powdery leprose lichens, we can see the leafy folios, and whenever we start to look at these beautiful mossy and lichenous sticks, we'll start to see all these different growth forms. So even in this one picture, there are so many different species going on. And if we zoom in a little bit further, we can see this classic club-like lichen. There's false pixie cap often in the Northern Hemisphere. We can see this beautiful foliose lichen extending down, and maybe some really obvious branching going on. Really nice to be able to get down low and have a look at those structures up close. A little tip if you're taking a photo on a phone, if you're taking a photo of something really, really close, use your 2 times or 3 times and be a little bit further away. It'll stop everything blurring on either side and it'll give you a larger depth of field, which means we can capture more of the structure. So a lot of these photos, I may not have been thinking about that because I'm just like, oh, a cool lichen. And so if you see it really, really blurry and it's only focusing on a tiny bit, it would be better if I was a bit further away and then zoomed in on the camera. And then we have our classic crustose. This is quite a classic lichen that we see on rocks, and I'll talk about where we find these in just a moment. And here we have our reindeer moss or caribou moss or reindeer lichen, and you can see it against the sphagnum moss here. Like, it is quite different once you know what to look for. The color is a really good indicator in this example, and this lichen extends above that beautiful forest floor. And we can see some really green ones as well, some really beautiful structures that come up. Once we start paying attention to our lichens, there's some really amazing diversity here. And so you can see a lot of different structures happening on the edges. This lichen, we've got our folios. It is a nice leaf-like shape, but we also have these little brown dots here. And we can see these brown dots sometimes on lichens throughout the year or through different seasons. And this is actually the fungal part of the lichen is trying to make little mushrooms on it. And so the fungal part is still trying to reproduce and still pass on its offspring within this lichen framework. And so sometimes you'll see these tiny little mushrooms coming out of the lichen, but it's actually the lichen reproducing. And it's really interesting because they are different species. They don't have their spores go together. Like algae doesn't grow that way. So the fungal spores get released and then they have to just hope that they line up with an algal species that they can form that lichen. They may hitch a ride, or you may see often lichen will fall to the ground. And so when you get those big clumps and something breaks off if an animal walks by, or if a stick drops from the sky and lands in a beautiful, nice bit of moist dirt, you might see that lichen able to then spread. So I've got a lovely little lichen stick here, and this is like 10 years old and it still looks green. It's just hanging on there. And so by using that vegetative growth, it's able to just drop parts of it. And then that way it's staying as a lichen altogether with its algae and its fungi. And that's a really good way for it to spread. So what are the lichens' likes and needs? So we kind of know that they grow in all these different forms. They can reproduce, they can move, they can do all the things that a lot of how we imagine plants would. There are things that they prefer. There'll be, obviously, it needs some sunlight to produce that food, some water, and nutrients, and space. So a lot of these needs are quite straightforward. Space I just want to touch on because the lichen is so unique. It's so well just adapted to put up with being in really extreme environments. We often see lichens in alpine areas. We also see it on exposed rocks right on the edge of a coastline that gets battered by storms. We can even see lichen growing on rocky outcrops in the middle of the desert. The lichens can go in so many different places because it's formed this entire unit where it can get most of its needs just by being both a fungi and an algae. It can make its own home and feed itself. Like it's very self-sustaining. And so it can put up with a lot of variation that other species just can't. And so when I think of space, I also think of the availability where no one else can go. If a plant can grow really, really well, it will, and it will take over all the light of a lichen. If a fungi can survive without an algae, it probably will. And so you'll have this fungal network that doesn't need algae. And so we see these lichens where we don't see other things. And that's a really important indicator of what's happening in those places. They could tell us about, sunlight, water, air, nutrients in those spaces because we don't have any other natural indicators. But they can also show some really cool adaptations, which I'll talk about in a little bit. So keep space in mind. So we'll just have a look at some of the places that these lichens are growing and why they're growing here. So this is a little outcrop at the Cape Willoughby Lighthouse in Kangaroo Island. And we can see this beautiful orange lichen on the tops of the rocks here. And we can also see this black streaking down a rock wall. We think of a lot of rock walls to be interesting, not just because of their geology and their beautiful facets where they break, but also the colors that we get from lichen. If you're looking up at a wall, even if you think of Yosemite National Park and they've got this beautiful streaking, a lot of that is lichen. The black lichens there are often exceptions because we're talking about 20,000 species, but often we see that black is streaking for lichens and sometimes some algae that really like more water. And so we see that as that water streak, and that water streak isn't because it's necessarily wet or dirty, but there's lichens there that are enjoying that moisture. Comparatively, this orange we can see is just on the top, and this orange lichen actually prefers it a little bit drier. This orange lichen, our orange sunburst, as well as one of the species that we see, really likes nutrient-rich areas. And you think, how can you get nutrients from rocks? Some lichens can actually take the nutrients out of rocks, and I'll talk about them in a moment. But the other thing that we find up on these rocky outcrops is often a lot of bird activity. And we can use lichens, especially these nice bright orange lichens, as an indicator for higher bird activity. So I might be looking here now for any nesting shorebirds. And they can be really, really helpful for keying in our eyes for other natural clues around the environment. Some other places we see our lichens is high up. This is by Australian standards, which is why I'm inverted commas, in our alpine environments, but you will see lichens in alpine environments all around the world. This is in Nipaluna Hobart in Lutruwita, Tasmania. And we can see some beautiful branching lichens at the base of the image here, but also quite a few different crustose lichens across the rock faces here. And they're really happy with the high winds and the cold temperatures because nothing else is growing there, so they get the space. They're able to kind of capitalize on that real estate, great views, and continue to grow where other plants may find it really, really difficult. Other species of animals may not be eating them as much. So the lichens are able to colonize and expand across this really quite cold, windy, considered harsh environment. This is at the very top of Australia. You can see why we don't have a huge ski season compared to other places around the world. This is not the height of winter, but I strolled up to the top of Mount Kosciuszko in the tallest region of Australia. And you can see there's lichens all over these rocks. And they're pretty happy. They're able to sustain very, very cold winters. They can sustain periods with not much water, but then they can also sustain being inundated with rains. So very, very well adapted. Think about some of our needs of water again. This is in Churchill. This is our lovely ptarmigan, our willow ptarmigan, and we're ignoring them. We're having a look at that beautiful orange lichen again. Looks like it's showing some bird activity for me, nice and high. But the feature here is really quite distinct when that water line comes down, and we can see that that orange lichen doesn't like to be where the water would come up to. So we get this almost tide line happening with the orange lichen. This can be because of the physical abrasion of that water as rubbing away the lichen, but also that lichen just can't sustain its life underneath the water. So we only see it growing on top. So now when there's no water, you can tell me where that tide line comes up to. So we're using the lichen's needs to tell us more about what is happening here. Here we are back in Australia. This is at the Remarkable Rocks. They are very remarkable. And this is on the edge overlooking the water, and we can see that orange crustose lichen again is on high points only, and we can see that black lichen is in the little gullies here, and they're where the water are going to sit for longer. Here the orange lichen is really just on that rock. It's not getting as much nutrient from anything else that's filtering down. There's no soil nearby, and the lichens with that fungal network sitting on the rock, clamping down on the rock, they can actually produce a really weak acid, but that weak acid can slowly break down the rock, and we can see erosion happening where that lichen is. So we start to see this like speckling, pancaking, and breaking off of rock where we see lichen that's been there for a really, really long time because it's able to take the minerals out of those rocks. And here we are in the Northern Hemisphere, and often we will see this sort of golden, really sort of greeny orange, so that really nice golden color of lichens. Generally likes to follow the sun. This is for a few species. And so we can actually see on this tree that the majority of the sunlight is going to be coming from the left of this image. And if you're in the Northern Hemisphere, we're going to see a lot more of that sun on the south side. So we can actually use this lichen as a navigation, and we can say, okay, where there's dominant lichen, that's going to be the south side. This does vary around the world, varies on the type of lichen, but what you can do is you can start at your home area and you can have a look and get to know your local lichen. So you'll know where the predominant sun is, you'll know where most of the wind and the rain blows in from. And so you can learn the lichen's reactions to those features. And then when you go a little bit further in your area, you can start to see those same lichens and how they react. And that's how you can practice and train. So get to know your local lichens, and maybe you can use them to navigate on your next hike. So apart from just direction, we can actually see the age of things. So we are going to introduce ourselves to map lichen. And it is used for a process called lichenometry, along with a couple of other species of lichen. This is map lichen, and I love this name because it means so many different things to me. Map lichen because it kind of looks like a map of an area. We have this beautiful green sort of land mass that's cracking with this black edge and these black lines throughout. So it looks a little bit like a map. The Latin name is Rhizocarpum geographicum, so geographic. We're thinking that's our map again. A map lichen can also help us map out the age of things, which is why I love it. And so lichen has been used to age things. Originally in 1933, there was a scientist who was using lichen to age any surfaces, but then it wasn't until the 50s when a technique was first developed by Beschel, and they were able to compare lichens to very specific ages to figure out how fast those lichens grow. And then if we count the largest lichen, we can say that that's the oldest lichen and therefore age how long a rock has been exposed in that same orientation in that area. And so, as this image suggests, he was able to use gravestones as a really good way to calibrate this metric, because the gravestones have a really nice handy date on them to show when they were put there. You can use that date to say how old those lichens are and therefore how quickly they grow. So when we see our map lichens, we're generally looking, depending on the species as well, but we get a growth range of about 0.9 to 0.3 millimeters per year. So less than a mil a year. It's really, really slow. So you can imagine how long this took. This technique is really, really helpful for aging things within the last 1,000 years. As we start to get older, it gets a little bit harder to tell because things will change the way that lichen grows. There's just a whole other host of factors that make it a little less accurate. But within the last 1,000 years is really quite useful. And if we compare it to a couple of species of lichen, we can get some really accurate dates. And this is really helpful because radiocarbon dating, which is the other dating form that we think of when we're aging biological things, which is using the natural decay of carbon-14, isn't very accurate within that short time frame because there hasn't been that much decay happening. So this kind of fills the gap between radiocarbon dating and then now we can use lichenometry. Pretty cool technique. And so now we can use our lichens as an age indicator. And what do we use this for? Like, why do we want to know? Obviously, the gravestones, we already have a date. But we can use this to see when potentially any seismic activity happened. We can also use it to see how the glaciers are moving. So whether they're shifting or receding, we can track that through now this rock that's exposed and it has lichens on it. We can age those lichens so we can see the rate at which that's moving beyond maybe our recorded history if we go back 1,000 years. So it does help us in a lot of different applications. Some of the other uses that we have for our lichens and some discoveries that we've had. I just wanted to point out this beautiful lichen because I clearly thought it was cool enough to stop and take a photo when I was out for a walk. This is Lobaria pulmonaria. Its common name is lung moss or lung lichen or tree lungwort because those really leafy-like structures, not true leaves, they have the appearance of the inside of lungs. And so they're quite sensitive to air pollution. And unfortunately, across Europe, where we see a lot of this, its population is decreasing in lowland areas. And so it is considered endangered there. But this lichen, not just beautiful, has many different uses. It's been used through a lot of different cultures across the Northern Hemisphere in North America and in Europe for herbal medicines. And we've recently studied to see that it does have anti-inflammatory properties and even ulcer preventing properties. At the same time, it's used to produce an orange dye, and it can be used in the tanning of leather. It can be used as an ingredient in brewing. So a lot of really interesting uses that are coming out of lichens with this amazing relationship between our fungi and algae. We're getting some really interesting properties. So many uses, and many that we don't know. This is our caribou moss or reindeer lichen or reindeer moss. And often when we're walking through the boreal forest, you'll see it sticking out above the moss. And this is a really important food for, you guessed it, caribou and reindeer. So as a lot of the other vegetation gets lost throughout the winter, within the boreal forest, caribou are able to still continue to eat the caribou lichen, and they get enough nutritional value to make it through the winter. And people who hunt caribou can also then eat the lichen from within the ruminant of the caribou. So it's like partially broken down, which is helpful, and are able to eat that. So we can eat lichens. This black crustiose lichen that is growing on these rocks here in Turkey is a rock tripe, and you can actually scrape this rock tripe off, and it can be used to be eating when food supplies are low. It's not the highest nutritional content. You can also put it in your soups to help thicken your soups. So there's quite a lot of different applications here. I mean, we eat mushrooms, so why not eating lichen? We eat seaweed, we eat algae. When we think about those components, it is just the same. But again, we've got 20,000 species, so we want to be careful what we get. Another use that we have for our animal kingdom is not just as a food source, but also as a bit of a defensive mechanism. So here we have a beautiful velvet gecko in Australia, and it blends in so well with this lichen-covered rock. And this lichen-covered rock has two types of lichen that I can see, that darker black, and then we have this beautiful, actually quite fine foliose lichen that's extending across. And the gecko has beautifully emulated that so that it can blend in. We'll see this also with a lot of species that'll use that dappling effect of lichen on rocks to mimic their camouflage as well. Often if an animal is just one color solid, it actually stands out. It looks really weird when it's just one solid color. So things like textures on the back, patterns, stripes, spots are really helpful for camouflage. So the last little thing I want to take you to is coming back to our beautiful map lichen, which I love, has so many different uses. It's already being used for lichenometry, but we can also take it not just from our remote mountaintops and our ocean cliffs and our desert environments, we can even take them to space. So our map lichen, our Rhizocarpon geographum, can survive in space, and there's been quite a few lichens that have been able to survive in space. So our map lichen has survived 2 weeks in the vacuum of space in one study, but we've also seen some other lichens that have been strapped to the side of the International Space Station for 18 months, and they have survived. So we've got the vacuum of space, we've got extreme cold temperatures, we have huge levels of radiation, up to 12,000 times the lethal dose for humans. And that lichen will just carry on photosynthesizing, creating food, surviving within that really strong structure, and just keep on producing. So I would recommend having a look at some of these papers, because we're not just looking now at lichens surviving in space, and some of them are just totally fine and continuing. Some of them may go into like a dormancy period, but then when they get to good conditions, they just spring back again. We also wonder if they could sustain life on Mars. So we have one species called Xanthora Paritina, which is another type of lichen that has survived the UV radiation, but it's also survived just recently in this paper at the bottom here, 2023. They simulated the conditions on Mars. So there's been a few lichens over the past 10 years that they've simulated ground Mars conditions and atmospheric Mars conditions and shown that some of these lichens can survive. And so maybe this will show that we can already have life on Mars, or that life can be sustained on Mars. And that's just through our amazing lichens. So food for thought, don't underestimate these guys. They are really, really amazing masters of adaptation. They've been around for so long and they tell us so much about the world around us. So next time you're out for a walk, you're going through a forest or through a rocky scape, you see a beautiful green covered wall, stick your face up and have a closer look and see how much life there is. Appreciate how unique and diverse it is. We have so many kingdoms of life in such a small amount of space. Get up close and don't be afraid to dive in and take some photos. Exclude that little coppertail skink there. And there's some beautiful lichens as well. And don't be afraid to take that wonky roadside photo of the lichen growing over our signposts, or even pose in front of your favorite lichen wall, like my mate Mike here. He studies lichens, and he had to stop in front of this beautiful dust lichen because he was super excited to see it. So I hope you enjoy. Thank you, guys. And if you have any questions, throw them out there.
Thank you, Nikki. That was adorable last photo. Thanks for sharing that. We do have some
so
questions for
happy.
you. I love to see it. I love it. Yeah. We do have some great questions for you, and I see some more coming in right now. I want to remind everyone, if you have a question today, you can submit that in your control panel under the questions field, and we'll take questions for the next 5 or 10 minutes probably. All right. Someone is wondering about lichens and if they can live or survive if they're exposed to salt water.
So a few lichens, like these seaside ones, would definitely be exposed to salt water. There can be different ways that you can deal with excess salt. We see this in the plant communities as well. One great thing that lichen does is it's just really tough. Like we see out in outer space, it's able to just, that shell on the outside, which is formed by the fungal network, is able to withstand quite a lot of things. So even if the salt is spraying on it, it can wait until that salt is maybe washed off or dries and flicks away. It's still able to continue to grow. It doesn't permeate in. The lichen will only absorb the nutrients that it needs, so it can just ignore the salt around it. And I've seen actually here, this is at the Remarkable Rocks, but we see the salt spray up onto these rocks, and you get these where the salt water has evaporated. You see these salt rings, and right next to it will be lichen, and the lichen can just choose not to have the salt. It does depend on the species, and they want to be adapted to that. If you then just threw salt on some lichens out in the forest, you're probably going to suck some moisture out because it's not used to it. But generally, they have pretty just hardy skins to deal with the salt.
That's so fascinating. So cool. Someone here is wondering about if lichens are growing on tree trunks and branches, are they drawing nutrients from the tree?
They can a little bit, but generally no, they don't necessarily need to. The fungal portion may take a little bit, but generally they're drawing all of their energy from the algae. So by and large, I'm sure there's probably a couple of examples where it doesn't because there's so many species, but by and large, we don't consider lichens to be parasitic at all. And so lichens can happily grow over trees without affecting the tree or the branch. You may then start to question if the lichen gets really big and overtakes an area just in terms of space and blocking some light, then maybe there might be a conflict there. But in terms of holding on to that branch, it's really just using that branch as like a substrate, as like a shelf to sit on. And it just helps to get it away from other things. So generally, it's actually quite a nice relationship, and you can admire that as much as you want, compared to something like maybe like a strangling vine or a really obvious parasitic plant, or we see a lot more parasitic fungi on their own. And those fungi are being parasitic because they don't have the algae to help them. They're on their own, so they have to start stealing food from the tree. But a lichen, it already has that algae food component built in, so it doesn't need to do that.
I love hearing about these dynamics between the species. It's so
There's so much
fascinating.
going on. Forests are so loud if we just know how to listen to it. It's amazing.
We've got a question here about using lichen for dating purposes, and so they're wondering if you need to know some sort of starting point before using that method, or if you can just dive in and write with the lichen.
So the lichen will expand and it will create new kind of like circles if we're looking at these crusting lichens. So you will see new rings develop. So what we do is we take a surface and we want to look at the largest lichen. There's actually a few different methods of dating depending on which species you look at and how accurate you want to try and be. Because it may be the largest lichen that you look at here, but 2 rocks over, there's a better one to be looking at. So often we look at that largest lichen, and that's usually going to be the oldest, and we're going to measure that one and ignore everything else. Another way that we do it is we take the 5 largest and we compare the 5 largest and maybe take an average, or we take a directed average. If you look up lichenometry, even just on the wiki, there's actually a really nice breakdown of the different methodologies. But generally, we're looking largest or 5 largest is quite common. And then measuring that. And yeah, it should just be that's been there the longest, and all the others are potentially offshoots of the same. And if we measure the growth and we know the growth of that species, then we can age that rock.
Mm. Next question here is about Lichen in Space, which sounds like a really fascinating movie. How
Yeah,
do
once I write that script.
how do lichens get water when they're in space?
Great question. They don't need water for quite a while if they can use the water that's already um, within their structure. So they're able to like make use of all the best things that they have at that point. We're actually taking as much of the CO2 as we can, which in a vacuum of space we don't have. So we actually just see this dormancy period. Generally, the growth isn't expanding a lot, but it's able to sustain itself because it's still creating some food with the residual minerals within the lichen that it's already brought with it. So you can imagine like if you were a seed and you can use up all the nutrients within that seed to still create a sprout for as long as you can, there's probably an upper limit. I'd be curious for the 18-month one to see how much actual growth happened versus just like sustaining its basic life and then coming back. When it comes back into those good conditions, it's fine. Mars becomes different because we're not looking at the vacuum of space. We actually do have an atmosphere, and it's able to use that CO2 from the atmosphere to continue to grow. So then that looks way more interesting and promising because we're looking at different atmospheric contexts. There's even questions on whether or not lichens can or have ever hitched a ride on like a meteor or an asteroid or a comet throughout space. Like there's so many questions now about this field we call astrobiology, and lichens are a really neat gateway into that. So yeah, have a little peruse.
That's amazing. We're getting close to the top of the hour, so we'll do one more question here. Looks like someone feels like they have some contradictory information. They were told somewhere recently that lichen was the very first life on this planet, but they're feeling like this presentation is maybe saying otherwise. Can you talk a little bit about that?
Yeah, no, I was trying to think of like what would you define as first life. I really believe that we're looking at our unicellular life is first. So if we think of our primordial soup as the look, but generally we started with single cell organisms, and then those single cell organisms started to combine, sometimes within, sometimes next to. We made our multicellular life. Lichen is very complicated. It is a symbiosis between multiple species, and it is multicellular, so it can't have come first. If we just think about the symbiosis on its own, we already needed two components to exist to come together. So it couldn't have been the very first thing, but it is one of some of the oldest things, and we've been able to see some lichen evidence in rocks that are 400 million years old, but it's kind of hard to tell exactly what's happening in those examples. Yeah, so definitely not the first thing on Earth, unfortunately, but components of it would be. So whether maybe they were suggesting that something within the lichen was the first thing. I'm thinking of our cyanobacteria that we know help to change the way that we see life on Earth. But even before cyanobacteria, there was some little things going on. So yeah, it's unfortunately not the lichen.
What about plant life? Was it the first plant life on the planet?
Well, they're not plants, so no. Yeah. um, it's coming down to that photosynthesis. That's the kickoff and the big discussion. And there's a lot of nuance if we're looking at exact terminology and what exists now versus what existed then, because we can only really see what has survived that long, and then we start looking at interesting fossil record stuff. We have some examples of lichen in amber that are 40,000 years old, super great. Amber is great, but it didn't exist for a long time. Plants would have come after our cyanobacteria as a way that they could photosynthesize. So again, we're coming from that single cell to our more multi-cell, more complicated. It's taken time to trial and error develop that. So who came first, lichens or plants? That is not clearly in my brain. I'm not going to call that. I should know that, but I'd have to look at the timeline.
Well, it's really absolutely fascinating. This whole presentation was so interesting, and it just every time I'm hearing a topic like this, it makes me really think about how complex the world is, and it makes me look deeper at the details that are around me rather than the larger picture. So thank you so much for this wonderful presentation. It's close to the top of the hour, so I'm going to hand it back over to you for any closing comments you'd like to make.
Thanks, Kendall. And I think you kind of just summed up what I hope to give through these series, is to just have a little bit of a closer look at the details around us, but also how that fits contextually into the world. There is a lot of nuance and complexity. There isn't a one size fits all, but there's so much going on that we can learn about and engage in that curiosity. And I think that really allows us to connect more with the world around us and have that empathy for our environment. And it's also just cool. We think of, I don't know, humans achieving all these things, and there's so many examples of nature just getting there first. So I just urge everyone to stay curious and go check out some lichens.
Absolutely great advice. Thank you so much, Nikki. And my thanks as well to everyone who tuned in today. Join us tomorrow for our next daily dose of nature. You can check out the week's lineup, including registration links on our website at nathab.com/webinars. We did record today's presentation, and we'll have the replay available on our website soon. And with that, I'll conclude the webinar. Goodbye, everybody.
See ya.